transformation. Transformation will start with like correct notations first. Okay. The original function y equals to fx undergoes some transformation and becomes to y dash equals to fx dash. So we need to distinguish between the before function and the after function first. Okay, before function and after function. Before function is in terms of y and x, and the after function will be y dash and x dash. Okay, before and after two functions. Okay, there are three types of transformation. I think you must have heard about that before. Translation, dilation, and reflection. Okay, that's the only three transformation method we use for linear transformation. Translation, dilation, and reflection. The order of describing the translation, dilation, and reflection is very important. So we follow a DRT rule. Okay, DRT rule is dilation, reflection, and translation. We always follow this rule. Okay. In the question, when the question gives you some transformation, it's not necessary to follow this rule, but when the question asking you to write this transformation, you follow this order, okay? Dilation, reflection, and translation. It's not the only correct way to do this, but it's the most efficient one, and the examiners will like this method more, okay? So dilation first, reflection, and then translation. So it will be different if I say I translate 1 unit up and then dilate 3 from the y-axis. It will be different from your dilate 3 units first and then translate 1 up. Okay, the order is important. You result into different graphs. Okay, so that's the order, and the basic shape of the graph after transformation will not change. So what that means, in other words, only the same type of functions can apply transformation to become each other. You have a linear graph, doesn't matter what transformation you have made to this linear, it won't become a quadratic. Okay, only linear can translate to another linear. Quadratic can translate to another quadratic. Say for example, 1 over x, your hyperbola function cannot be transferred to the truncus function. Okay, it doesn't matter what you have done. The only exception is the sine and cosine graph. They can transform to each other. Okay, the only exception is the sine cosine, but you won't like really learn this in year 11. That's a more year 12 type. Okay, sine and cosine. Why sine cosine can translate to each other? Think about the graph. Okay, sine graph and cos graph looks pretty much the same. Okay, it's all the curve thing. Okay, so sine cosine can become each other by transformation. Okay, and number 5 is the thing I just talked about. Mapping is the best method I find to deal with. Okay, so mapping. What we all learn here after here is mapping. Okay, we start from 7a. So 7a is a translation. So we talk about 3 different transformations one by one. So the first one we talk about is the translation. So translation will be the easiest one, moving right, left, up, or down. Okay, move this graph. Okay, whole graph moving like that. So let's have a look what we have. Translate A units to the right. Okay, first is the language. Okay, the language of transformation will be very unique. Okay, you must follow one of the things I write here. Okay, when you describe it, you can't just say some random things you think makes sense to you, but doesn't make sense to the examiner. So you need to follow some particular ways to talk about those transformations. Okay, first is translation. How do we describe translation? I'll say translate A units to the right. Okay, that's the first way to say it. Or I'll say translate A units in the positive direction of x-axis. Okay, both of that will be correct. Okay, translate A units, let's say translate 2 units to the right, or translate 2 units in the positive direction of x-axis. Okay, so what that will do for mapping. Okay, remember you have your original x and you have your new x. Okay, that's the x from your old graph. That's the x from your new graph. Okay, that's from the new, that's from the old graph. Okay, let's have a think. If you translate a graph A units to the right, okay, let's say 2 units to the right, you have the point 1, 2 at the beginning. Okay, I have a point 1, 2 at the beginning. What the result graph will be? Result point. Translate 2 units to the right. 3, 2. Okay, what has been changed? Your original x is 1, your new x is 3. So what you can write for this one is x dash will equals to the old x plus 2. Okay, that's mapping. So what your new x compared to the old x? The old x plus 2 will become your new x. Okay, your old x plus 2 will become the new x. Let's say instead of 2, I'll write a. Okay, so a units to the right. Your old x plus a units will be the new point. Okay, that's the first thing. The second will be translate to the left. Okay, translate a units to the left, or translate a units in the negative direction of x-axis. Okay, it's moving the graph to the left. Okay, your old x subtract this a will result in the new x. So your new x needs to be equals to x minus a. Okay, that's the mapping. Okay, according to this sentence, what I can write is x dash equals to x minus a. And then it's moving left or right, and then moving up or down. Translate b units up. Okay, translate b units in the positive direction of y-axis. It's moving up. If you have 1, 1, if you translate 2 units, that will become 1, 3. So your y value will add the value you translate up. So the y dash, the new y value, will equals to the old y value plus the units you translate up. Okay, so your old y going up by b units will give you the new y value. So that will be pretty much the same if you do translate b units down. Okay, translate b units down. So y dash will be y subtract b. Okay, the most difficult thing for mapping method is how you can distinguish between x dash, y dash, and xy. Okay, which one equals to which one plus something. Okay, so it must be the new point equals to the old point plus or minus the thing you have done. Okay, moving up or down, left or right. So according to those 4 sentences, what I can write is those 4 lines. Okay, those 4 lines. Let's have a look at an example. Example 1. Find the rule. Okay, find the rule for the image. Okay, find the rule for the image. You must have y dash x dash. Okay, for the image, you must have an equation with x dash y dash. Of this graph, y equals to 1 on x. The original, okay, the original. And a translation, 2 units in the positive direction of x-axis. Okay, according to this one, what I can write? Translate 2 units in the positive direction in the x-axis is a horizontal movement. Okay, move to the right by 2 units. So what you know is the new x must be the old x plus 2. Okay, translate 2 units in the positive direction is x dash equals to x plus 2. And then 1 unit in the negative direction of y-axis. So your y dash must be equals to the old y minus 1 is translate 1 units down. Okay, 1 units down. According to the red line and the black line, we can write those 2 equations. Okay, the next thing will be important. Let's write this here. Okay, y equals to 1 over x. That's your original graph. It's in terms of y and x. Okay? If I want to do substitutions, I can't substitute this x dash into this x. I can't substitute this y dash into this y. So I need to rearrange this equation. I'll make x equals to x dash minus 2 and y equals to y dash plus 1. Why I make xy to be the subjects? Because I want to do substitution. If I want to do substitution, I have x and y. Therefore, I must have xy to be the subjects for the original equation. Therefore, y can replace to y dash plus 1 equals to 1 over x. X is x dash minus 2. Okay, we have that. We change x into x dash minus 2. We change y into y dash plus 1. Okay, then y dash equals to what? Y dash equals to that subtract by 1 to make y dash to be the subject. I can take off the dash. Because with the dash, without the dash, it doesn't make any difference now. Because I just want to find the equation. And that will be my final equation. I just take off the dash, okay? You like already have the new, okay, y dash x dash. The equation is already in y dash and x dash. I know that's the thing I want, and then I can take off the x dash and y dash. I know you can do this type of question really easily by looking at it, because moving to the right by 2 units will be -2, and moving down by 1 unit will be subtract 1. But do not use that method. You will, yep.
You know how you're writing the equations and you're working out, so you have to have the y dash.
Which y dash?
As in like, you're working out like in the blue.
Yep, that one?
Like, as in like, for previous steps, you have to have the dash there.
Okay, so after you already substitute here for this step, x dash, y dash already, you can take off the dash. Yeah, you can take off any time. Just do not confuse yourself. Like, it only leaves x dash, y dash in the equation. So the x dash, y dash is to distinguish between the new function and the old function. So if you know that's your new function already, you can start to write x, y later. Okay. Okay, I have another question. Find the rule for the image of the graph of y equals to that. Okay, you have your y equals to x plus 1 squared minus 2. It must be in terms of xy because it's asking you to find the image. Okay, you are asking to find x dash, y dash. So you must have the original one. Okay, that must be an original one. Okay, and a translation 3 units in the negative direction of x-axis. What you can write? What you can write? Translate 3 units in the negative direction of x-axis. X dash. Okay, must be the new point. Okay, the new point equals to what? The new point equals to the old points. Okay, the old points doing what? Translate 3 units in the negative direction, so -3. Okay. The next one is 2 units in the negative direction of y-x-axis. What I can write? Y minus 2. That's correct. Okay, and then let's have a look at. We have x and y. We don't have x dash and y dash. So we need to make xy to be the subject. Okay, x equals to x dash plus 3, y equals to y dash plus 2. Okay, repeat again why do we need to rearrange this equation? Because I have x, y in this equation and I need to substitute x dash, y dash into the old equation. Okay, so I need to have x, y to be the subject. So replace y, I have y dash plus 2 to replace y. To replace x, I'll have x dash plus 3 to replace x. But don't forget, you still have a plus 1 here. Squared minus 2. Okay, that's replaced. Okay, how we replace that? Okay, y can be changed to y dash plus 2. X can be changed to x dash plus 3. And then I can take off the dash now. Y equals to x plus 4 squared minus 2 and minus another 2. So y equals to x plus 4 squared minus 4. Okay, that will be my final answer. Okay, that's the equation of the image. Okay, type 1 question. Okay, that's type 1 question. What we have done here is type 1 question. So there are 2 main type of questions. Okay, what's type 1 question? Type 1 question is give you the original equation. Okay, give you the original equation and give you the word description to describe the transformation applied. Okay, or in matrix. Okay, matrix is something we'll learn after this. Okay, so give you an original equation, give you the word description, and write the new equation. Okay, ask you what is the new equation. Okay, go back to have a look. We have the original equation and we have the word description for the transformation applied, and ask us to find the new equation. Okay, that's type 1. So how do we do type 1 questions? I would say according to the word description, write the equations for x dash equals to something, y dash equals to something. Okay, x dash equals to x plus 2, y dash equals to y minus 1. Step 2, rearrange the equation to make x, y to be the subject. Okay, x, y to be the subject. Let's say we have y minus 1 here to make x, y to be the subject. Number 3, substitute x in terms of x dash, y in terms of y dash into the original one. Okay, replace y into y dash plus something, replace x into x dash minus something, and then make y dash to be the subject. Okay, last step makes y dash to be the subject, and that's your final answer. Okay, you follow those 4 steps. Okay, you follow those 4 steps. Okay, let's have a look at example 2. Example 2 is type 2 question now. Okay, we finished type 1. Okay, I will just draw a line here. What you have above is type 1 question. And now let's have a look at type 2 question. Okay, type 2 question I think is a little bit trickier than the type 1. Okay, I like type 1 question more. But what has been described in type 2? Type 2 question is describe the transformation. Okay, what is asking is describe the transformation. Ask you to write transformations by yourself. Okay, describe the transformation. Transfer this graph to this graph. Okay, transfer this graph to this graph. So the first thing I will do is distinguish between the new graph and the old graph. How do we distinguish between them? We have x dash y dash in the new equation. So y equals to square root x minus 1 plus 2 is still the original one. And the new one is y dash equals to x dash plus 2 minus 1. That's step number 1. Okay. Put dash on the new equation. Okay, we have dash on the second one. From this to that. Okay, number 2. Equation. Step number 2. Step number 2 will be, okay, this will be the tricky step. Okay, this will be the tricky step. Move all the constant and coefficient all to the left. Only leave the model on the right hand side. Okay, what can be a model on the right hand side? Square root can be a model. F bracket something can be a model. 1 over something can be a model. Okay, 1 over something squared can be a model. Something squared or something to the power of n can be a model. Okay, I only want to leave those kind of things on the right hand side. All the coefficients all to the left. Okay, all the coefficients to the left. Okay, what are the equations we have learned so far? That's all we have learned. But we also have sine something. On the right, sine, cosine, tangent. On the right. Okay, so what can be left on the right? I will put it on in red. Okay, square root of something. Square root of something. Anything else needs to go to the left. So that will become y minus 2 equals to square root x minus 1. And you have y dash plus 1 equals to square root x dash plus 2. That's step number 2. Okay, leave the model on the right and leave all the constant coefficient to the left. Okay, step number 3 will be the important step. Equalize both sides. Equalize both sides. Y minus 2 equals to y dash plus 1. Okay, don't need to include the model itself. You just need to think what you put in the model. You put in x minus 1 into the square root. So you just need x minus 1 equals to x dash plus 2. what have been put in the model, that's the thing you put in that model. Those two things will be equalize each other. Step number 4. Okay, step number 4 will be the point you need to think. Okay, all of that you just need to rearrange, equalize. Okay, number 4 you need to think about. Do you want to make x dash to be the subject, or you want to make y dash to x to be the subject? Okay, whether it's x dash y dash to be the subject or x y to be the subject. X, Y, okay, so it depends on what you need to do, okay? It depends on what you're trying to do. So for the previous example, I'm trying to do substitutions. So I need to make x, y to be the subject because I have x and y. Okay, for this question, I want to do word descriptions. I want to describe what is happening. Okay, I want to describe what is happening. So I want to describe, compared to the old graph, what the new graph is. Okay, so the transformation will be what has been done to the old graph. In other words, it's like, what's the new graph? New graph equals to the old graph plus something or minus something. You need x dash y dash to be the subject. You need to know, okay, the new one equals to the old one going right to 4 units or going down by 3 units. You need to make x dash y dash to be the subject because you want to know the transformation. How you can know the transformation? Okay, let's go back. You know the transformation. You can write x dash y dash to be the subjects. Okay, if you know x dash y dash, you can also going back to the transformation applied. So you need x dash y dash to be the subject. So y dash equals to y minus 3. X dash equals to x minus 3. Okay, so what you can say? Okay, I can say is translate 3 units to the left. Okay, because x has been subtracted by 3. The old graph has been subtracted by 3. And then translate 3 units down. Okay, moving down by 3 units, y minus 3. Okay, this is according to that, and this is according to that. It doesn't matter with the order. Okay, it doesn't matter with the order. Which one you describe first doesn't matter because they are all translations. Okay, they are all translations. Translation can happen, doesn't matter with the order. Okay, describe the transformation that transfer y equals to fx to y equals to fx minus 3 plus 2. So first I will write those two equations. Distinguish between the new one and old one. So the new one must be in terms of xy. The new one must be x dash y dash. So it's f x dash minus 3 and plus 2. Number 2 is rearrange the equation, only leave the model on the left hand side. So I will say f something or g something, even though we don't know the actual rule, but like f something already can represent the rule. So this x is what you insert in this rule. And then this side you must have that. Okay, f something, you insert x dash minus 3 into this function. So y still equals to fx, and y dash minus 2 will equals to f x dash minus 3. Equalize, okay, equalize. Y will equals to y dash minus 2. X must be x dash minus 3. Don't include the f. The f is a rule. I don't care about which rule is that. I just care about what I have inserted into this rule. So it's x equals to x dash minus 3. So y dash equals to y plus 2 because I want to know the word description. So I need to make x dash y dash to be the subject. So x will equals to x plus 3. So number 5, I'll describe it. That will be translate 3 units to the right and translate, I can say 2 units in the positive direction. It's better to write in the positive direction one. Positive direction of y-axis. You can write up, but like you won't lose mark. Okay, just expect like this one's more clear in which direction and from which axis. But like it's okay to write left, right, up and down. Okay, this is type 2 question. Okay, this is type 2 question. Type 2 question will give you the original one, give you the result one, and ask you to describe the transformation has been applied. Okay, so give you both equations and ask you what has been transferred, like left or right, up or down. Okay, I'm not going to go through the steps, like you know the steps. I have write number 1, 2, 3, 4, 5. Okay, that's the 5 steps. Okay, do a little bit about dilation. Okay, dilation and reflection. I want to finish the mapping. Okay, I want to finish about the mapping method. Dilation by a factor of A from y-axis. Okay, dilation is the most, is the one like you can make mistakes. Okay, the description is very important. Okay, I will say just follow with the first one. Okay, do not worry about the second one and third one. The second and third one is for you to understand. Okay, the second and third one is for you, like when it appears in the question, you will know what transformation has been applied. But for the first one is the language you use to describe your transformation by yourself. Okay, so for the first two. Okay, what has been said is dilation by a factor A from the y-axis. Okay, how to think about this graph? From x-axis, let's say we have xy graph. Okay, I will draw that on the board. I'll draw that on the board. Okay, you have xy graph. What is dilation? What is dilation by factor A from the x-axis? What means by from y-axis? Okay, if you have a graph here, you will stretch it this direction. Okay, you will stretch it this direction. It's actually changing the x. Okay, have a look at the second one. Dilation by a factor of B from the x-axis. From the x-axis stretch this way. It's changing the y value. Okay, so it's changing. Okay, one is change x value and the other will be change y value. Okay, if you say that if I dilate by a factor of 3 from the y-axis, okay, dilate by a factor of 3 from the y-axis. If your original point is 1, 2, then the point will, let's say 3, 2, then the point will become 9, 2, okay? Dilate by a factor of 3 from the y-axis. Therefore, what you can write is x dash equals to a times of the original x. Okay, x dash equals to a times of the original x. And be familiar with the second and third description. Okay, I can say dilate by a factor of a parallel to x-axis. Okay, if I say parallel to x-axis, it's changing x value. Okay, if it's from y-axis, okay, from y-axis is changing x. Parallel to x is changing x. In the direction of x is changing x. Okay, all of those three is changing x values. Okay, here is from y, here is x and x. Okay, do not mix up with the descriptions. Okay, so all of those three is talking about changing x values. Okay, similarly, you have changing y values. Dilate by a factor of b from the x-axis, or dilate by a factor of b parallel to y-axis or in the direction of y-axis. They are all changing y values. So if they are all changing y values, your new y needs to be equals to b times of the original y. If you have a point 1, 2, dilate by a factor of 3 from the x-axis, then will be 1, 6. You times the y value by the dilate factor. Okay, so for example, 1, 2 will become 1, 6. It's a dilation by a factor of 3. Okay, dilate by a factor of 3. You times the y value, old value by the dilate factor, that will give you the new value. So new value equals to the old value times the dilation factor. Okay, that's dilation. In dilation, I have two. Okay, one is dilate from y-axis and dilate from x-axis. Okay, dilate from two different sides. Okay, next one is reflection. Next one is reflection. So reflection is the mirror image. Okay, reflection is the mirror image. So let's have a look at first. Reflect in the y-axis is change x value. Y is change x value. Okay, dilate, reflect, let's say we have a point 1, 2. And reflect in the y-axis, you have here negative 1, 2. Okay, it's changing the x values. It's changing the x values. So what you can write for this reflection, x dash equals to minus x. X dash equals to minus x. So your new x equals to negative of the old x. And say reflection in the x-axis. So in the x-axis, you have point like that is actually changing the y values. Okay, change y value. If it's change y value, what you can write is y dash equals to minus y. Okay, y dash equals to minus y. Okay, it's changing the y value. Okay, example 1. Let's have a look at example 1. Write down the equation of the image. Okay, write down the equation of the image. That will be type 1 question. Okay, write down the equation, image equation. So it must be in terms of x dash and y dash. Obtained when y equals to 1 over x squared is transformed by a dilation of factor a half from the y-axis. From the y-axis is changing what value? X. Okay, from y-axis is changing the x value. So what you can write is x dash equals to a half x. Okay, it's changing the x value. X is changing the x value from the y-axis. So x dash equals to a half x. Next one is a dilation of factor 2/3 from the x-axis. Which value is changing? From the x-axis, y. So y dash equals to 2 on 3, y. Okay, the equation you have is the original equation. So y equals to 1 over x squared. So you have x and y to be the subject. Okay, x, y. So you need x, y to be the subject. So x will equals to 2x. Y will be 3. Y will be 3 over 2. X equals to 2x dash. Y is 3 over 2. Y dash. And make x, y to be the subject. Then y will become 3 over 2 y dash equals to 1 over 2x dash. Okay, that's in the box, and square. Okay, replace the x and y. So y will equals to 2 over 3 times 1 over 4x squared. Okay, flip the fraction to the side. Yep. Well, like you want to simplify things, because that 4 can simplify with this 2. So that's why I'm trying to open the bracket. 1. So what value? Yeah, you can keep it. You can keep it. So that's 1. That's 2. Y will equals to 1 over 6x squared. Okay, I want to simplify to the simplest version. Okay, so I will have 1 over 6x squared. Okay, the next one we have is reflection. Reflection by the x-axis is changing what value? Reflect by y value, okay? Reflect by x-axis is changing y value. So y dash equals to negative y. And reflect in y x-axis is changing by x value. So x dash will equals to minus x. So you still have the same equation on the top, y equals to 1 over x squared. Okay, you still have x, y to be the subject. So you still need y equals to minus y dash and x equals to minus x dash. So y will replace to minus y dash, that equals to 1 over, replace the x by minus x dash, squared. So that will give you y equals to minus 1 over x squared. Minus x dash squared is x squared, because the minus just gone, we squared it, and the minus moved to that side. You have minus 1 over x squared. That's your final answer. That's the final answer for part 1. Okay, the last one. Okay, the last question is easy. Okay, it's type 2 question. That's type 2 equation. Okay, that's type 2 equation. Describe the transformation applied to y equals to square root 2x to make it become y equals to root 3x. Okay, so what I can have is y equals to root 2x, y equals to y dash equals to root 3x dash. Okay, the old one, the new one. Okay, leave some space. Okay, leave some space. I need to talk about another things later. Okay, just use half of the space. The model is square root. Okay, the model is square root. Is that and that. Okay, nothing happened to the y side. Okay, y equals to y dash. Nothing happened. Y dash is still the original y. To the x side, I have 2x equals to 3x dash. Okay, what do you insert in the model? The model is square root x. What do you insert in? It will be that. So x dash equals to 2 over 3x. Okay, you divide 3 on both sides. X dash equals to 2 over 3x. Okay, it's a dilation. It's a dilation. It's a dilation by a factor of 2 on 3 from which axis? Yeah, from y-x-axis. Because it's changing the x value, then it must be from the y-x-axis, okay, this direction, from the y-x-axis. So it's dilated by a factor of 2 on 3 from the y-x-axis. Okay, now I want to do something weird. Okay. I will show you something. So let's do y equals to root 2 times root x. Y dash equals to root 3 times root x dash. I separate them. What's the model? The model is square root with the term x. It's that one and that one. So the root 2, root 3, it doesn't helpful. Okay, it doesn't helpful. So it needs to go to the left. So y over root 2 equals to root x. Y dash over root 3 equals to root x dash. Okay. Now what you can write is y over root 2 equals to y dash over root 3. And x equals to x dash. Nothing happened for the x side now. Okay, nothing happened for this x side. But dilation happened at the y side. So what y dash equals to? Y dash equals to root 3 over root 2 y. Y dash equals to root 6 over 2 y times root 2 on both top and bottom. Okay, nothing happened for this x side. Okay, nothing happened for this x side. So this is a dilation by a factor of root 6 over 2 from, okay, it's changing y value is from which axis? Which axis? X, okay, x-axis. Okay, I have two different dilations. Okay, I have two different dilations. Which one is correct? Both. Okay, good. Both. Both of them are correct. It depends on how you treat this 2 and 3. You think this 2 is combined with your x, or you think this root 2 is combined with your y? Okay, so what this question actually showing us is, if I can dilate something from the y-axis, I must can dilate this graph from the x-axis as well by a different factor. Okay, if I can dilate from the y-axis, it must can be done by dilate from the x-axis by a different factor. Okay, so if you can stretch this direction, I can also stretch in this direction by different factors. Okay, so dilation is not only got a unique answer, it can get like different kinds of answers, like multiple answers. You can have infinite many pairs of solutions. But like from this question, the obvious one is this one. Okay, the obvious one is this one. It's changing the x values. That's the obvious dilation. That one is just without with a little bit thinking, I can also can be done by x-axis. So why I'm doing this? Because in some multiple choice, it not necessarily got the answer you think is correct. Okay, for example, you work out this answer, but it's actually the solution is this one. Okay, the option is this one, not giving you this one at all. Okay, can give you something dilate from a different x-axis. Okay, so you need to know both of them. Okay, you need to know all of them. You need to know, okay, not only one way to do dilation. There's always more than one way to do dilations. There's infinite many ways to do dilations by different values from different x-axis. Okay, so that's I want to make. Okay, that's the point I want to make from this question. Okay, that's it.